Hello everyone. As you may already know, it's crucial to understand the proofs of the sum of the first n terms of natural numbers, arithmetic series, and geometric series for the CCEA A2 Unit One pure maths exam. Today I will present those proofs to ensure you're well prepared for your exam. Let's begin. Firstly, I will demonstrate to you how to prove the sum of the first n natural number. Let s equal to 1 plus 2 plus 3 plus n minus 2 plus n minus 1 plus n. And we rewrite this in a reverse order. So we start with the last term, the n term, and then the n minus 1 term. And that ends with 3, 2, 1. We name those two equations as 1 and 2. And we add equation 1 and 2 to give the left hand side to be 2s. The right hand side would be 1 plus n, and then 2 plus n minus 1, and then 3 plus n minus 2, and then n minus 2 plus 3. We use the next line, and then plus n minus 1 plus 2, and then n plus 1. And we simplify this. The right hand side, we have n plus 1, n plus 1, n plus 1. And the last return, n minus 2 plus 3, that also give n plus 1. And then n minus 1 plus 2, that also give n plus 1. And the last term is n plus 1. And here we know we have n of those, n plus 1. So we can simplify further. That give you n times n plus 1. And we divided by 2 on both sides. That gives you the nth term is n 1 over 2. That concludes the proof for the sum of the first n natural numbers. Next, I'm going to demonstrate how to prove the sum of the first n terms of arithmetic series. We know that the n terms of arithmetic series is an equal to a plus n minus 1 times by d, where an is the nth term, a is the first term, n is the position of the terms in the sequence, and d is the common difference. You will likely notice that natural numbers form an arithmetic progression, where the first term is 1 and the common difference is also 1. Consequently, the second term is obtained by adding 1 to the first term, resulting in 2. This pattern continues, with each subsequent term being calculated by adding 1 to the previous term. Therefore, we can apply the same approach used to prove the sum of the first n natural numbers to demonstrate the sum of the first n terms of arithmetic series. let Sn equal to A plus A D, that's the second term, and then A plus 2D, that's the third term. Uh, the last term is A plus N minus 1D. This is the nth term. And we label this as equation 1. And we rewrite equation 1 in the reverse order. So Sn is equal to A plus N minus 1D. And then the next one would be A plus N minus 2D. And the last three terms would be A plus 2D plus A plus D. The last one is A. And we label this as equation 2. And we add equation 1 to equation 2. That gives the left hand side 2Sn. And the right hand side is A plus A plus N minus 1D. The first term in the first equation are the first term in the second equation. Okay, and so on. You have the second term, adding the second term. And then the last term. And we simplify this. We keep the left hand side the same. And we have n of those terms. So we simplify further. This becomes n times 2a n plus 1b. And we divide by 2 on both sides. That would give half n 2a plus n plus 1b. That's the end of the proof of the sum of the first n terms of an arithmetic series. Finally, I will show you how to prove the sum of the first n terms of a geometric series. The nth term of a geometric progression is a times r to the power n minus 1, where a is the first term, r is the common ratio, and n is the position of the terms in the geometric progression. And we let Sn equal to a plus the second term with ar, third term ar squared, and the last two terms will be a r to the power minus 2 and m term is a times r to the power n minus 1. And we call this equation 1. And equation 1 times the common ratio r, that will give you r as n equal to a times r, and then r square r cubed a n plus 1, and the last term will be a n. I will call this equation 2. And we subtract 2 from 1, that gives you left hand side is 1 minus r as n. The right hand side, we cancel all the terms in the middle. That gives you a minus a r the power n. And we divide by 1 minus r on both sides. That gives you s n equal to a plus a r power n plus r. And we factorize the top. That will give you 1 minus equal to 1. This concludes the proof of the sum of the first n terms of a geometric series. Next recap. I have demonstrated the proofs of the sum of the first n natural numbers, the sum of the first n terms of an arithmetic series, and the sum of the first n terms of a geometric series. All those proofs are necessary for the CCEA A2 Math Unit 1 paper. If you like a copy of the proof mentioned above, please send me a private message. In my next video, I will demonstrate the proof of the double angles formula in trigonometry. Stay tuned. If you found my videos useful, please like, share, and subscribe to my channel. Goodbye.